So negative and rational exponents. We are going to see both of those in our problems today. What does a negative exponent do? We did kind of talk about this earlier, last week I think. Right, so if you have a negative exponent on top, it would go down the bottom. If something on the bottom has a negative exponent, it goes to the top. If you have a fraction and something on top and bottom, what do you do with those exponents? Subtract. So we have written these rules down before, but if you forgot them, a negative exponent just moves it down to the bottom. And if you have the same base, you subtract exponents. So we have been using those rules already. But we haven't encountered a lot of the negatives yet, so that's what we're going to start seeing today. All right. If you have a fraction exponent, does anyone know what that means? If I say like x to the 2/3, what does that tell us? So this one you probably definitely need to write down then. If we have a real base and a fraction exponent, that turns it into a radical. The denominator of the exponent is the index on the radical. The numerator can go either inside or outside the radical. It's equivalent either way. So for instance, when I say x to the 2/3 power, that means you have the cube root of x squared. If I said x to the 1/2, a 1/2 power would mean you have a square root. So first we're going to just look at some problems and try to evaluate using exponent rules. First ones have numbers, so I don't want to just plug them in our calculator because eventually we're going to have variables. And if you have variables, can you just plug it in and get the answer? No. So we need an understanding of what they actually mean. So if I asked you to find 10 to the -3rd. First thing we always do is rewrite it so we don't have negative exponents. So what does the -3rd tell me? So it's just a 1 on top. What is 10 to the 3rd? That means 10 times 10 times 10. 10 times 10 is 100 times 10 adds another 0, so 1,000. -5 to the -1. Can I just say 2 negatives make positive? No. The negative out in front is just going to trail along. Then I'm doing 5 to the -1. So what's 5 to the -1? 1/. Right. It's 1/5 to the 1st, but do I need to write that 1 anymore? No. We don't have an exponent, we assume it's 1. So the negative in front just stays, so our answer is -1/5. If I said 4/9 to the -2 power. So the negative puts it on the bottom, but I don't really want to write 1/4/9. If you already have a fraction and the whole fraction is to a negative power, what do you do to your fraction? You just flip it. So instead of 4/9, it becomes 9/4. And then since I flipped it, it is now a positive 2 power. Alright, so 9 squared is 4 squared, 81/60. You would definitely check to see if it could reduce at all. I don't think they're perfect squares, but they don't have any common factors, so we can't reduce it. We can only do it if they're both divisible by the same number. M to the -4. Remember, exponents only touch what's directly in front of them. What is directly in front of my exponent? Just the n. Okay, so the m is going to stay where it is. So do I have to write it as m times 1/n to the 4th? No, we just make one big fraction. The m did not have a negative exponent, so it just stays on top. The n drops down. So an n to the 4th on the bottom. Alright, this one. So now the whole thing is to the -4th power. So now the whole thing drops down to the bottom. How could I rewrite the bottom? M to the 4th, n to the 4th. That exponent goes to both. Those were some of the exponent rules we talked about before. All right. Any issues with these? Well, let's try some more. So I want to simplify. It's always going to tell you all the variables represent non-zero numbers, just because if it ends up on the bottom, it can't be a 0. So that doesn't really change our process for solving this at all. What would I do on A? What do we have to do with those exponents? Subtract them. The 15 doesn't change, so 8 minus 3 is 5. If you wanted to do 15 to the 5th, you could. It's a pretty large number. What would give us? 759,375. I would accept it if you just said 15 to the 5th. Now, if it's something small, 2 to the 3rd, go ahead and simplify it. But otherwise, if you leave it, it's no big deal. On B. What would we do there? Okay, you can flip first. first. Does everything have a negative exponent? No, just the y to the negative 9th. So y to the 4th had a positive exponent, so it stays. Since we had a negative exponent on the bottom, it will move up to the top. Then, if you're multiplying and the y is written each time, what do you do with your exponents? Add them together, y to 13.
Could you just do 4 minus negative 9?
Yes, you could. The other option, these were dividing, and we've said before, if you're dividing, you subtract exponents. So 4 minus negative 9 also is y to the 13th. So both ways work. C. So if I am asked to reduce this, it's all one term, so we can break things down. 35 and 25, what would that turn into? 7/3. Okay, my r's. So either way, do you want to subtract them or bring it up first? Subtract. So it's just 6 minus negative 4. So r to the 10th, and that's on top. Because 6 is bigger than negative 4. D. 34 and 51. Do those reduce? Alright. My A's. Will this end on the top or the bottom? Do we have more A's on the top or the bottom? The bottom here. So we'll go down the bottom. And then you subtract, so 12 minus 8 is 4. Will my B's end up on top or bottom?
Top.
And subtract 11 minus 6 is 5. Doing okay with these? Do you guys think you could try a couple problems on your own? Alright, so I'm going to put a few up here. Same thing, I want you to simplify, make sure you don't have any negative exponents on your final answers. We had to think more. Order of operations, where do we begin? The exponent. So, our exponent rules say if you have a power to a power, you have to multiply. So I have to multiply it to both exponents that are there. Negative 1 times negative 3 is positive 3. 4 times negative 3 is negative 12. Now, you're used to seeing parentheses and thinking, I have to distribute. But that's if there is an addition sign here, more than one term. There's no addition. This is just one big multiplication problem. So we're multiplying together the things that we can. So this is like saying we have a 5 times an x to the 3rd times, what is 2 to the 3rd? Times an x to the negative 12. What is 5 times 8? X to the 3rd times x to the negative 12. Right, we have to add those exponents. And then, to finish, anything with a negative exponent goes to the denominator. So we get 40 over x to the 9. Do we have a question? Question?
Where's the 8?
2 to the 3rd power
Oh,
means 2 times 2 times. Other questions? So B, It's all one term, no addition or subtraction, so that means we can just reduce things. 30 and 45, what does that reduce to? Okay, we have r's on top and bottom. Which one's bigger? 4 or negative 6? So we are going to subtract negative 6, so that gives us r to the 10th. Alright, s, do we have more on top or bottom? So we are going to subtract our negative 9, so that's s to the 12. Alright, let's do this one together. So there is a lot here. Where would we begin? Yeah, let's deal with all of these exponents up here. So this is currently like a 4 to the first. Power to a power, what do we do with our exponents? So we have to distribute that negative 2 to both of them, multiply it with the exponent that's already there. So 1 times negative 2 is negative 2. B, 3 times negative 2 is negative 6. So I took that first parenthesis to the negative 2. Second one, my exponent is negative 3. So again, this is a 4 to the first. So if you multiply your exponents, 1 times negative 3 is negative 3. With my b's, negative 1 times negative 3 is 3. On the bottom, distribute my negative 4. So negative 1 times negative 4, b, 3 times negative 4, Alright, there are a lot of different places I can go from here, but let's just focus on the numerator for now. This is all one big multiplication problem. Even though we have parentheses, there's no addition or subtraction, so we are just multiplying the things that we can. So if I multiply my 4's, what do I do with those exponents? Add them. So negative 2 plus negative 3 is negative 5. With my b's, add those exponents. Negative 6 plus negative 3, or plus 3, sorry, is negative 3. All right. Yes.
How come you wouldn't like multiply 4 times 4?
So think of it like this. If I had positive exponents, okay. This first one says you have 2 4's. The second one says we have 3 4's. So if I put them together, I still have 4's, but now I have a total of 5 of them. So the base doesn't change, just the exponent. Now if we wanted to go ahead and do 4 to the 5th power, we could. I just haven't gotten there yet. Other questions? All right, what do you want to do next? Subtract exponents. So let's ask ourselves, where will it end up? Do I have more 4's on top or bottom? So you're looking at the exponent. Which one is bigger? Negative 5 or positive 4? Positive 4. So I'm going to subtract negative 5. So that will give me 4 to the 9. With my b's, which one is bigger, negative 3 or negative 12? So I will subtract negative 12. So that gives me a positive 9. You'll know if you took it to the wrong spot because you'll have a negative exponent still. And if it's negative, you just switch 4's. So the negative on top drops down the bottom. Negative on the bottom comes up to the top. At this point, could we do 4 to the 9th if you wanted to? Yeah. It gives you 262,144. So I would accept either one.
So on the, go back a step, it's 4 negative
So, kind of,
Because 4/4 is 1.
right, but it's like saying essentially, if you have 4 to the 5th, that's 5 fours. When you have 4 to the 4th, that's 4 fours. Even if you cancel things out, it doesn't change the fact that we have 4s remaining. So the reason that we didn't get rid of them entirely, it has to do with the negative a little bit, but when you are dividing, we never get rid of our base, we just subtract our exponents. Okay, or if you don't like the subtraction thing, you could say, well, 4 to the -5th, that could come down to the bottom and it would be a positive. And we had a 4 to the 4th on the bottom. So you have 5 fours here and 4 fours here, which gives you a total of 9 fours.
So then why were we able to simplify like 2 problems ago? It's like 34 was 51 or something. It was 2/3.
Mm-hmm.
Why were we able to do that?
Because 34 can be written as 2 times 17. 51 is 3 times 17. And here we had 117 on top, 117 on the bottom. If you subtract 1 minus 1, it's 0. So it took away all the 17s. So you have to think about the exponent rules. You know, when you're dealing with your variables, it doesn't change the exponent. This is saying you have 8 a's on top and 12 on the bottom. So you can cancel out 8 of them, but you still have 4 a's remaining on the bottom. Other questions? Okay. I am going to stop with the new stuff today, but I am going to throw a review problem up that I want everybody to do, okay? All right. How come I've been canceling on the problems I've been doing today, but I can't cancel first on this problem? Right, we have to factor. We can only start reducing when things are a single term. All the problems we've been given today, there was no addition or subtraction. It was all one term, so you can just start canceling. Here, I have addition and subtraction, so it's multiple terms. I need to make it a multiplication problem, so it's a single term, and that way we can reduce. So 6a minus 24, we can take out 6. 3a minus 15, we can take out 3. What did we do if it was a division problem? Yeah, change it to times and flip. So, a squared minus 3a minus 10. What multiplies -10 adds to -3? Okay, a squared minus 16. So now, it's all a big multiplication problem. So now we can reduce if anything's on top and bottom. So those cancel, these cancel. What about 6 divided by 3? What is that?
2.
2 over 1. So if you multiply, you have 2 times the a plus 2, 1 times your a plus 4. Or you could write 2a plus 4 over a plus 4. Okay. Tomorrow I will probably do some more review problems at the end, so we will finish the section that we're on. I'll probably do some addition, subtraction review at the end. Try to hit that every day since we'll have a test coming up next week. There is a math Excel assignment open, but you'll notice the due date is Monday because I'm not done with it yet. So you have today and tomorrow we're teaching this lesson, and I always make it due at 3 o'clock the following day. Okay, so it's one assignment for the next today and tomorrow.